Okay, so this actually is a the code that you're seeing here is an actual Java implementation of single server queuing system that we studied in simulation modeling. What we have to import from the libraries is just the utility library, and the language library with all the import statements, and then we are making a class with public static void main, that is the initialized main के सिवा तो वो execute भी नहीं होगा. So like it's the starting point of the function, right? What we need to do is like we need to first initialize a couple of things. Let's discuss one of them. Like let's discuss each one of them, right? We need a random number since it involves simulation, and it also involves probability as well. We need a double u variable. U variable is just for the purpose of serving the log and mathematics, right? And then n is the total number of servers, or maybe total number of events that could even occur, right? So this would be given in the question. Now we have double lambda. Lambda is 1.0, which is given into the question. Lambda is like the arrival. Mu is like the what we say, like lambda is arrival, mu is the inter-arrival time, or maybe we could say like the mean time, right? So this is inter-arrival time. I hope you got it. I have written it here too. Lambda is arrival, IAT is the mean or the inter-arrival time 1 upon lambda, which is also known as mu. So mu needs to be written here like this. Okay, so coming back to this, we have these given in the questions as well. Double infinity. Infinity is like infinity, or maybe infinity could be stated as 999. Okay, it could be any number multiplied by n. N is the total number of maybe the possible outcomes, or maybe occurrences like we had, like, or maybe servers we have like in our queuing system. Not the server, or maybe the couple of objects that are to be coming into the single server queuing system. And mu is the mean that we have already initialized earlier. The other thing around is int n is equals to 0. This is a state variable that needs to be changed across multiple places in arrival or departure event that we are going to discuss next. Na is the arrival event that is happening and that we need to initialize here, because it's going to change variously rapidly. Nd is departure event, and which we initialize here again. T lambda is obviously it would be needed to calculate. We need to calculate Ta with that, with T lambda. T mu is obviously initialized again. T lambda, total lambda, is again a variable that will be needed for the calculation of wait time, response time, and stuff. Mu, total mu. Then we need to find out or maybe initialize an array Ta with new double and n plus 1. Since we need to have it have a response times noted in an array, so what we need to do is like we need to create an array for that purpose, for that sole purpose. We need to find response and wait. For wait we need response, so we need to calculate both at the same time. U is then again I told you right here, U would be the log used for the log purpose, and would be our random integer as well. Random integer that we are taking from the random variable, random number. I hope that is clear. Again, we are generating a random number from generator, next double, and then obviously the thing remains the same. Ta, meanwhile Ta, what we see here is Ta. Ta is the arrival arrival event that we are seeing, and that is calculated by minus log u divided by lambda. So it's like minus log u divided by lambda, right? So that's for the arrival event, since lambda is arrival value or arrival variable that is taken into consideration. Total lambda, that's total lambda again, we have is equals to Ta in the initialized conditions, because since total lambda is dependent on the arrival event. Okay, so now if we are to calculate two events, obviously this system is gonna have like two events in total. That is first arrival, and the second one would be departure. So in this particular piece of code, what we can deal with is arrival event. So what we see here is like in every condition we need to check that every time the nd is a departure event, less than should be less than the total number of events that are gonna occur right here. So the next thing that we have to check is for every condition, whether it is an arrival event or it's a departure event, it needs to be less than n. N is the total number of events. Now the next thing round here is we need to take care of we need to see that if it's an arrival event. For that purpose, we need to take out TA less than TD. So if it's an arrival event, it's gonna be less than TD, because TD is gonna be more than arrival if it's an arrival event. क्योंकि अगर arrival event एक बार हो जाएगा तो TD क्या हो जाएगा, एक बार हो जाएगा तो वो डिक्रीज़ हो जाएगा and will be less than TD. TD would be departure event. तो अब दूसरों की बात करते हैं कि फिर जब हमें पता चल गया कि अराइवल इवेंट है, तो उसको T वेरिएबल को जो हमें टोटल टाइम बताएगा, तो उसको इनिशलाइज कर देंगे TA के साथ, एंड देन n++ कर देंगे, यानी कि सिस्टम स्टेट को चेंज कर लेंगे. जो 0 से थी अब वो 1 पे हो जाएगी, क्योंकि n जो रिप्रेजेंट करता है वो स्टेट को रिप्रेजेंट करता है. NA++ कर देंगे, क्यों? क्योंकि अराइवल इवेंट है. फिर देख रहे हैं कि अगर अराइवल इवेंट लेस देन इक्वल्स टू n है, जो हमें बार बार चेक करना रहना है ताकि हम उसको पॉसिबिलिटीज़ तक लेके जाएं, तो हम लोग उसको जो भी वेरिएबल है NA का, उसको हम एज अ TA की जो हमने यहाँ पर इनिशलाइज़ की थी, तो उसको उसके अकॉर्डिंगली रख देंगे, यानी कि उसकी एज एन इंडेक्स पोजीशन पे रख देंगे. गॉट इट? एंड देन व्हाट वी गोना डू इज़ इनिशलाइज इट विद द T वेरिएबल, जो हमने पहले बोला था TA के बराबर है, क्योंकि अराइवल इवेंट अकर हुआ है पहली बार. फिर उसके बाद हम लोग U जो वेरिएबल है, वो जो नीडेड है, उसको हम लोग जनरेटर डॉट नेक्स्ट डबल से जैसे हमें चाहिए मैथमेटिक्स के लिए वो करेंगे, और फिर T लैम्डा मालूम करेंगे. जैसे वो किस तरीके से मालूम होता है, -log U डिवाइड बाय लैम्डा. सही है, सो दैट्स क्लियर. फिर T जो लैम्डा मिला है वो हम TA की कैलकुलेशन के लिए यूज़ करेंगे. TA इज इक्वल्स टू T प्लस T लैम्डा. ठीक है. फिर टोटल लैम्डा जो ढूंढना है उसको हम लोग कैलकुलेशन उसमें लाएंगे विथ T लैम्डा. T lambda is like the calculations that we had earlier taken from log U statement, right? So total lambda मिल गया, हमारी condition satisfy होगी. That's it. That's what we wanted to do, right? For the purpose of arrival event. T lambda is the identification of an arrival event. Now the next thing if n is equals to 1, so this means that the first arrival has occurred and the system state before had no any arrivals. So that is indication of first arrival. U is equals to, in that particular condition, what you have to do is like initialize the U variable with the generator, random number generator, with T mu. T mu is the again the time or the maybe that is inter-arrival time event, okay, IAT event, and then minus log U and divided by mu, just like we calculate for minus log U lambda. TD is equals to T plus T mu, and total mu is plus, and then the T mu that we calculated from log U will be used for the purpose of calculating total mu, just as this total mu works as a sum variable that just gets incremented every time with other particular logic here, which is T mu respectively here, T lambda respectively here. The other event that we have in store is that departure event. If we are saying that if this condition doesn't happen to be like that, arrival event isn't happening, then we have the only possibility left, that is the departure event. So T will be initialized with T departure, and then obviously system state will decrease, because what we are trying to do is we don't have any more arrival event but more like a departure event. So departure event needs to be incremented. Then we're gonna say like response plus equals to TA, and then T minus TA, and ND. ND is the departure event that we need to initialize in our TA array that we already initialized on our first basic step. Then we're gonna see if our system state is equals to 0, what we're gonna do is like, it's a basic initial nascent state, right? So what we're gonna do is like put the departure event of that particular state into infinity. Why do we need to do that? Just because of the whole purpose कि हमें बोलना है कि भाई अगर अराइवल 0 है तो हम लोग उसको फर्दर उसको सिस्टम को स्टेट को दें, तो सही एक पर्टिकुलर लिमिट नहीं उसको क्रिएट कर दें, बट उनको रादर वी शुड बी जस्टिफाइंग दैम विद सेइंग कि हम आपके पास इस सिस्टम के अंदर अराइवल इवेंट्स और डिपार्चर इवेंट्स आ सकते हैं. सो जस्ट डोंट वरी अबाउट दैट, लाइक इट्स लिटरली कंसोलेशन, right? So just making it easy with the easy layman terms, right? So else अगर ये ना हो, अगर ये फर्स्ट इवेंट इनिशियल फर्स्ट इवेंट ना हो, तो हमें क्या करना पड़ेगा? एल्स यू इज इक्वल्स टू जनरेटर नेक्स्ट डबल, जैसे हम करते हैं. फिर टी म्यू की कैलकुलेशन करेंगे जिस तरीके से करते हैं. फिर टी डी की कैलकुलेशन करेंगे, टी प्लस टी म्यू, एंड देन टोटल म्यू की कैलकुलेशन करेंगे जैसे हम लोग प्रीवियसली करते आ रहे हैं. फिर हम लोग वेट निकालेंगे. वेट कैसे निकलता है? रिस्पॉन्स माइनस टोटल म्यू एंड देन डिवाइड बाय n, right? So what we have to do is obviously response हमें कहाँ से मिला? Departure event से मिला. Minus total mu is like total mu divided by n. N is the total number of events that are to occur. And then what we're gonna do is print out IAT Q time ST. IAT कैसे निकलेगा? टोटल लैम्डा डिवाइड बाय NA. सही हो गया. टोटल लैम्डा हमने प्रीवियसली कैलकुलेट किया हुआ है. Q टाइम जो है वो वेट ये होता है हमारे पास. ST यानी कि सर्विस टाइम जो होता है वो हमारे पास टोटल म्यू डिवाइडेड बाय N होता है. तो उसकी कैलकुलेशन प्रीवियसली हम लोग करके आए हैं.